In this video, we are calculating x, that is the chord length, and the chord is in a circle. Let's say it is 10 millimeters. MC is 10 millimeters. The question is saying calculate the chord. So what will be the chord here? The chord will be between points A and points B. So we have to use the formula. So this is the formula that's on the formula sheet. So you have to manipulate that formula. And so the formula manipulated will be x is equal to the square root of 4h open brackets d minus h. Notice the 4h is multiplied by all that's in the bracket. Next step would be to substitute. Now notice, in order to do this question, the diameter will need to be given because d in the formula is diameter, or if a radius is given, you know that the radius times 2 will give you the diameter. The radius is 13 in the question, so now we will substitute 26 for d because why? The diameter is double the distance of the radius. Notice that the height of the chord is 10. Plug all that into your calculator and then square root the answer. And so our answer will be 25,30 units. So if it was millimeters, your answer will be millimeters. If it was meters, your answer would be meters. And this is how we find the chord length. Do note that x is equal to AB. The next question we're going on here is to calculate volume, okay, volume of this cylinder. So remember, this circle is actually the top of a cylinder. And so the next question is saying calculate the volume of the cylinder. So let's say the question says volume is equal to pi r squared h, right? And it's given. Then we'll substitute 75 for h if the height is 75. And don't forget, with r is you're going to put the radius. Notice that the radius is 13 in the question. So multiply all that out on your calculator. Don't forget it's 13 squared. So 13 squared times 75 times pi equals. Right, that will be my answer. And do note that volume is in units to the power 3. So it's units cubed. Right, we're going to go on to the next question about a rotating wheel on a car. So in this question, we're looking at a car's wheel, and the car's traveling at 100 kilometers per hour, right? So it's traveling at 100 kilometers per hour, and the radius of the wheel is 350 millimeters. So notice that one is in kilometers and the other one is in millimeters. So that we're going to need to do some conversion here. So the first thing, I want you to convert the speed to meters per second, and also convert your radius to meters. So from millimeters to meters, we divide by 1,000. So this will give me 0.35 meters. Remember that the diameter is twice that of the radius. So 2 times 0.35 will give me the total diameter. So my diameter will be 0.7 meters. Now we're going to take the 100 kilometers per hour and convert it to meters per second. 100 kilometers per hour means exactly that. 100 kilometers divided by 1 hour. So we're going to change that into meters per second. So you have to ask yourself, how many meters are there in a kilometer? So multiplying that by 1,000, we'll get 100,000 meters. And how many seconds are there in 1 hour? 3,600 seconds in 1 hour. We can see we are dividing meters by seconds, so our unit is going to be meters per second. So this means 100 kilometers per hour is actually 277.78 meters per second. 27.78 meters per second. So 27.78 meters per second is equivalent to 100 kilometers per hour. We also have this term called rotational frequency. Now, what is rotational frequency? Rotational frequency is the n value. So remember, in the formula we have velocity is equal to pi dn. Now notice that n must be in revs per second. And if it's in revs per second, it is then the rotational frequency. Okay, because frequency is per second. So notice, if we have a velocity that's already in meters per second, then this is a very easy question. We're going to substitute 27,78 for the v. So manipulate the formula and make n subjects of the formula. Then you're going to substitute. The v is 27,78 in the numerator, pi, and what was your diameter? 0,7. Plug all that in your calculator. So your rotational frequency will be 12,63 revs per second. Remember that rotational frequency must be in revs per second. If it was in revs per minute, this means you'd have to do a conversion to bring it to per second. So next I want you to calculate for me the circumference. So the circumference of that same circle you see. So circumference is equal to pi times diameter. So pi times, and what was the diameter? 0,7 meters. Punch that in, give us a decimal. So the circumference is 2,2 meters. So the next step. Now let's say I want to calculate that point A, what distance it will cover in one revolution, right? So notice if A makes one full turn, right? I want to know what distance it will cover in one revolution. Now we know that we have 12,63 revs in 1 second. So clearly we have one revolution, right? So one revolution is how much, right? Think about it. If I complete one revolution, what distance would I cover? So that would be the circumference, correct? So one revolution is equal to the circumference. So where I see the word revolution, I can even put circumference there. Right, so we know the circumference is 2,2 meters calculated times the n, the revolutions per second. So one revolution times the revs per second, that will give us, right, and it will give us 27,79 meters per second. So we can take that and multiply it by 10 seconds to find out how far that we will travel in 10 seconds. So the total distance after 10 seconds, so multiplying it out, we'll get 277,9 meters in 10 seconds. Okay, and that's how we're going to get the total distance the wheel will travel after 10 seconds. In other words, point A. Right, so notice in one revolution, that means it makes one circumference. One circumference is 22, right? Times the rotational frequency or the rotational speed. So speed times the distance will give me the meters per second. And then I'll get the final answer in meters when I multiply by seconds. And this will be the total distance covered after 10 seconds. Okay, that's the video. Happy learning.